Betting on horses, God, and your API. So my name is Don Goodman-Wilson. As you said, I'm a developer advocate at sqreen, and I want to talk to you a bit about security, because this is what we do. I'm not going to talk to you about sqreen. Don't fear, this is not an advertisement. I want to talk about security broadly, and I want to talk about the fact that so many people that I encounter now and certainly before at places where I've worked and companies where I've met, when asked whether or not they do security, they say, well, no, because the chance of getting hacked is so minute. I mean, we're on nobody's radar whatsoever, that it's simply not worth the cost of us thinking about this. And I want to argue that this is a terrible argument. Argue that this is a terrible argument? No, I want to claim that this is a terrible argument and then prove that it's a terrible argument. And I'm going to do that with this guy. This is Blaise Pascal. French people in the room should recognize him. He's like a national hero. He invented the mechanical calculator. Without him, we wouldn't have computers. He was one of the early thinkers in probability and statistics. And he also liked to think about God, because he was also an amateur theologian. And as part of the scientific revolution sweeping France, he began to realize that there's literally no empirical evidence that we could ever find for God's existence. We have no way of knowing if God exists. So why should we believe in God if we can't know if he exists? And so he thought really the question to ask is to treat this as a wager, right? We can answer questions about wagers. He was a betting man. He understood how these sorts of things work. And he was part of the forefront of a field that was trying to develop mathematics to explain how wagers work and how one, this is the important part, how one chooses rationally in the face of uncertainty. So we're uncertain about God's existence. How do we choose whether to believe in God? Well, he said, we bet with our lives as to whether God exists. It's a very easy way to turn this into a bet, right? And now, once we have this paraphrased as a bet, we can do a payout matrix. And so this is what a payout matrix for God's existence looks like. So along the top, we have the two bets you can place, for God, against God, and the two possible outcomes. God does not exist, God does exist, all right? So let's just look at what the payoffs are, because it turns out the rest of it won't matter too much. So if we bet on God and God doesn't exist, nah. If we bet against God and God doesn't exist, nah. But if we bet on God and God does exist, that's right, hallelujah, everlasting eternal life in heaven, right? So infinite payoff. But if God doesn't exist, then we're damned to eternity in hell, and we have negative infinite payoff, right? So very straightforward payoff matrix. And then he observed the interesting property. If we treat them as zero and the other ones as positive and negative infinity, what's any number times infinity? Infinity. What's any number times zero? Zero. We don't care about the probability that God exists. It just falls right out of the equation. It's amazing, right? And so, too fast. And so he says we should bet on God, right? There's an infinite payoff if we bet on God and we happen to be right, but negative infinite payoff if we bet against God and we happen to be wrong, right? Regardless of the fact that God's existence is possibly a very slim possibility, or maybe it's a very great possibility, doesn't matter. So we can do the same thing with our startups, because I'm here to talk about security. So here's a new wager. We bet with our startups as to whether we will suffer a debilitating attack. We don't know if we're going to get hacked in the next 24 months. We don't know if our security is going to be effective against that hack. It probably won't even happen. So let's treat it as a wager, and let's see what happens. So we're going to do the simple thing first and just apply the same payoff matrix here, right? So we can either bet on security or bet against security, and we either never get hacked or we suffer a debilitating hack. And what does this payoff matrix look like? Much the same. If we bet on security and we're never hacked, right? If we bet against security and we're never hacked, all right. If we bet on security and we suffer a debilitating hack and the security stops it, and we know that the security stopped it, we're pretty happy. We're not infinitely happy, or infinitely happy for an infinite period of time for that matter, but we're pretty happy. But if we bet against security and we suffer a debilitating attack, and by debilitating, I mean, you can see I'm setting this up, right? By debilitating, I mean wipes out your startup. Then from the startup's point of view, it's pretty close to negative and infinite unhappiness. Wait, infinite unhappiness, negative infinite happiness. It's pretty bad. And so what I want to argue here, first pass approximation, not an argument, is don't bet against security. Don't. I mean, it's just stupid, right? Because if you bet against security, you're going to get hacked and you're going to regret it. Well, maybe you get hacked. Actually, even if it's a very small chance that you get hacked, the regret that you feel is going to be so great that your CTO is going to kick your ass and your VCs aren't going to fund you again. So that's fun. But let's do this a little more seriously. So this kind of thinking that Pascal devised around his wager eventually made its way to modern decision theory, and we call this expected utility theory. I want to give you a real quick primer as to what expected utility theory is, and then run through these two examples again in a much more nuanced way, right? So now we're not just laughing at things and going, oh yeah, of course Son's right. Now comes the math. Oh yeah, by the way, there's going to be some math. Yeah. We'll try to make it easy. So here's the math. This is a central theorem of expected utility theory. So the idea is to enumerate all the possible actions you can take in a scenario. We're just for now going to boil it down to two: bet against God, bet for God; bet against security, bet for security. And so that's A. The function EU of A, that's the expected utility of A. So expected utility is a measure of, on average, if you were to repeat this experiment many times, what your payout would be on average, basically, for performing this action. And we're going to use it to make a decision about whether we should perform this action just once, right? Because we only get one chance to do this. And we need to compute this for each possible action that we want to take, and then we just take the action with the greatest expected utility. Très facile. So then the next stage, the other side of this equation. I know those of you watching online can't see me pointing my laser pointer at the screen. Look at the big sigma. So we're going to do a sum. We're going to do a sum over all the possible outcomes. So remember, the other axis of the chart was the outcomes: God's existence, God's non-existence, getting hacked. And so for each possible outcome, we're going to look at the probability of that outcome occurring, given the action that you've taken. That's the conditional probability there, and multiply that by the utility of that outcome in conjunction with the utility of your action, right? So we have to take both the outcome and the action together, because the action may influence the outcome. And we same with the probability of the outcome occurring, right? The action may influence the outcome occurring in one way or the other. So first of all, deep breath. We're going to apply this. So, oh God, more math. This is not so hard. This is what it looks like when we expand out Pascal's wager. So B is the predicate belief in God. That little thing in front of the B in the second line, that's not belief in God. Very straightforward. So, and then the rest of it reads on the top, the probability of God's existence, given that you believe in God, times the utility of God's existence and the fact that you believe in God. And then the other four terms here, here, and here are just the same thing, but with variations on where the not is placed. All right, so we're summing over all the outcomes for EU of B and all the possible outcomes for EU of not B. So we can substitute in. We can simplify this immediately. Does God's existence depend on my belief in him? Probably not. I think God exists independently of whether I want him to or think he should. So we can simplify those probabilities greatly already. They're not really conditional probabilities. We can't affect the outcomes in this way, right? And as for the expected utility of each of the outcomes, we've already got that from the chart we just made earlier, so we just substitute those in. Doing good so far. Remember the property of infinity and the property of zero that I pointed out earlier? Yeah, so those probabilities just fall away. So the expected utility of believing in God is infinite, and the expected disutility of not believing in God is infinite as well. Therefore, we should choose to believe in God. QED. So I'm not really here to talk about God or to convince you to believe in God. I'm here to talk about security and to convince you of security. But it just turns out that Pascal had a very interesting argument and a very useful argument structure. So let's think about security. So we're going to build another payoff matrix. It's actually going to be slightly different than before, because we're going to add a little nuance and a little realism to it. So here it is, once again. So if we bet against security and we do not get hacked, we're actually a little happy, right? We cheated the system. We got by. We didn't incur any costs, and nobody hit us. So not bad. If we bet on security and there's no hack, then we're a little side-eyed, right? Like, well, we dropped all this money. Feels a little unjustified, but at least we didn't get hacked. It's not the worst possible thing ever, but if we bet against security and we get hacked, then we've just lost a big chunk of change. If we bet on security and we get hacked, we've also not only lost a chunk of change, we've spent money on security that was ineffective, and we're crying like babies because we've made some critical mistake somewhere along the way. So that's fine. So now how do we actually put this into mathematical form? Well, we need several things, right? So first of all, we need the likelihood that we're going to get hacked, right? And the likelihood of getting hacked really is conditional in this case on our action. If we take proactive steps to avoid getting hacked, that's going to affect the outcome, right? It's going to make it much less likely that we get hacked. So we should handle that nuance as well. We also need to know, like, what are the costs actually, right? I've made some funny emoji here, but if we put some actual numbers in here, we can flesh something out. So the question I'm going to ask is, given these parameters that I'm going to pop in here, is it rational to choose to pay for security? So the first question, how likely am I to be hacked? I don't know, right? This is a really hard one to answer. The only thing we can do is pull people's intuitions, really. I mean, we can't even look at historical data, in part because it doesn't exist. Nobody's really going to tell you how often they've been hacked and how much they've been hacked for. That's really hard to get. But even if we do, it's a bit of a complicated bit of actuarial work that I really wasn't willing to jump into here. So I turned instead to the second best expert on the field, Twitter. And I polled some large number of people as to how likely they thought they would be to see a serious hack over the course of the next 24 months. And I got a much larger number of high responses than I was expecting. This is a logarithmic scale. So if we take a logarithmic average, it comes out to about 1.1% is the average response here. So all right, 1.1% chance to see a hack. Well, let's pop that in our table. This time we're going to look at the likelihood of successful attack rather than the payoff, right? So the likelihood of each of these payoffs occurring. Twitter says 1.1% here. We subtract that from 100 to fill in this box, and we get 98.90%. Okay. What do we put in the next box? Let's suppose for a moment, we're just going to suppose that we're going to invest in a security regime that will eliminate 75% of the kinds of hacks that we're talking about. This is just made up. You need to know what your own security regime is capable of. You need to have an estimate put in here, but I'm going to say it'll stop 3 out of 4 attacks. I'm going to say 3 out of 4 because that sounds kind of shitty, actually. I would like it to stop much closer to 100%. Let's just go with 3 out of 4 because it's not terrible. So the probability of being hacked given a bet on security then drops to 0.275%. You with me so far? Okay, so in the next box, we just subtract that from 100. We fill that in. We have our probabilities. Great. Now what about the cost of a hack? Here I'm seriously just going to make up some numbers because hacks are going to, who knows how much it's going to cost you in the end. So let's just suppose that if you don't get hacked, it doesn't cost you anything. That seems pretty reasonable, right? And if you do get hacked, it's going to cost you $1 million, right? $1 million in bad PR, $1 million in lost goodwill, $1 million to recover assets, to deal with lawyers, to hire a PR firm. It's probably not a big hack. This is not debilitating scale. Let's suppose, moreover, that we're going to spend 5,000 euros over the next 24 months on security. That's the other option on the table. It doesn't have anything to do with sqreen's pricing. And then if we are hacked and we bet on security, then we just sum these two things. We spent 5,000 euro, we lost €1 million, right? So we're down 1.005 million euro. Is it rational to spend that 5,000 euros, given a 75% reduction in being hacked? Let's find out. All right, so here's the math again. It's exactly the same as before, but to be confusing, I've swapped out some of the letters. S is bet on security, H is getting hacked, right? So we've got the conditional probabilities, we've got the expected utilities, and we're just going to substitute in from the two tables, right? So here's our probabilities of getting hacked. I'll put these on the web if you want to check my math later, because I would really appreciate that. It's really hard to put LaTeX into Keynote. And then here are the disutilities incurred for each of these possible outcomes, and we do the math. And so the expected utility, or we should say the expected cost over 24 months of betting on security is about 7,750 euros, and betting against security is 11,000 euros. Now, it doesn't seem like a lot of money. That doesn't seem like a huge difference between these two things. But remember, this is a tool for decision-making and choosing what's rational, right? If we expect to pay less by betting on security, then that's the rational choice to make at these rates that I quoted. So QED, we should bet on security. Oh, that's not a QED. That's fine. So, is this context realistic is the next question. Are the assumptions realistic? Are the parameters realistic? And the answer is, I don't know. It depends. It depends on your particular circumstances. It depends on your particular security regime or lack thereof. And you need to run these numbers for yourself to see. And I'm building an online calculator that would allow you to run these numbers for yourself. It's not ready yet, unfortunately. But you need to consider the likelihood of a hack, the cost of a hack, and the effectiveness of the proposed security regime along with its cost as well. But once you have those, you can run the numbers and make a decision about what's rational. For those of you in the room who are wondering, though, what should you be spending this money on, right? If it's rational to spend 5,000 euros over 24 months on security, what does that mean? Well, we have an answer. We have this thing called the CTO security checklist. It's a vendor neutral, I'm going to emphasize that it's vendor neutral, list of the things that, the best practices for security at various stages of startups, right? And it's meant to be well-rounded, practical, actionable advice for proactive steps you can take to ensure that you don't end up in where did that go? In that scenario in the bottom right. So, my name is Don Goodman-Wilson. Thank you very much for your time. You want to do questions? Or are we gonna?
Yeah.
All right.
5 minutes of questions. Listen. Do you believe in God?
I'm what you call a strict agnostic. I not only believe that there's no possible evidence for or against his existence, but since we're getting personal here, I also believe that there's no possible justification for believing in him or not.
Yeah.
Despite the argument I just gave to the contrary. I have different counter arguments against that I'm not going to deploy because that would undermine the punchline of my talk.
Who else is in your space? What other competitors or companies?
Sure. So in our space, so for those who don't know, sqreen is, not that I get to do the pitch, web application security. So we have a module that you import into your web application and it provides security at runtime within it. Competitors in that space, there are a couple of other products on the market that do similar things. The Signal Sciences, or are they WAF? I'm going to look over here to these people. Okay. Yeah, Immunio.
Yeah, Immunio. I don't really know. T-Cell, but yeah,
yeah,
not a lot.
Signal Science is probably a competitor at some point.
But we are still the best, so.
It's very true. And you might think of WAFs, web application firewalls, as being competitive. They work on a different kind of technology and a different layer. And so that although there's overlapping functionality, really, I think the two work together as part of a well-intentioned, multi-layered security regime. Yeah. They're different. Anyone else?
Other questions?
No? All right. Well, thank you all so much for your time.